The first thing we're going to be considering is the base of the exponent, as given by the title here, the base b. We will be considering two different bases, but what we're going to be doing applies to any base. So we're going to use the two that are most often used in our studies, and that is base 10 and the base of the natural logarithm e. And these bases are related by the following equality. 2e raised to the 2.303 is equal to 10. And therefore, 10 is equal to, or 10 raised to the 1 divided by 2.303 is, which happens to be equal to 10 raised to the 0.434 is equal to e. So these equalities will enable us to convert freely between the two bases. And so exercise 1 is conversion between these two bases. For example, we're going to have to note that 10 squared is equal to, we substitute in the first equality, e to the 2.303 for 10, and we raise that to the second power, and the rules of exponents require that when I have raised an exponential number to an exponent, I have to multiply. So this is comes down to knowing when to multiply and when to add. And so I multiply these two numbers and I get e to the 4.606 is equal to 10 squared. And example B, I take e squared and I substitute in 10 to the 0.434, which is the same as e, which is equivalent, that equality, and I raise it to the second power. Again, it comes down to knowing when to add and when to multiply. In this case, we multiply, like we did before, and that's equal to 10 to the 0.868. So, given these examples, let's now do a few exercises, and there are more exercises provided for you in the handout, but we'll just do the first 4 to get you warmed up. And they carry the most salient features, but the first exercise is to convert the given exponential form into the other base. So we're either going to go as 10 or e, which base, if I give you a number that's in base 10, you have to convert it to that same number in base e. Or if I give you something in base e, you have to convert it to that same number with base 10. And so example A, I have 10 cubed. So let me get my pen. $10 cubed. We substitute in the equality for 10, which is e to the 2.303, and this is raised to the third power. So now all I have to do is multiply through, and you may need to, on a test, you would do this part, the next part you might do on scratch paper, or you could do this one in your head. Well, 3 times 3 is 9. That's again 9, and 3 times 2 is 6. So I think we can do this one without scratch paper. You can almost do this one in your head. That's equal to e to the 6.90. And now the second one we're going to do, number B, I have to convert from the base e to the raised to the fourth power to the equivalent expression using the base 10. So I'll start with e to the fourth power, the given information. I substitute in the equivalent expression with base 10, which is 10 to the 0.434th power is e, and I raise this to the 4th power, so all I have to do now is multiply through. And in this case, I'm sure that many of you could do this one in your head, but I'm kind of slow, so I'm going to do it over here on some scratch paper. So this is on my scratch paper, 0.434 times 4 is that's 16, 3 times 4 is 12, that's 13, 4 times 4 is 16, and 1 is 17, 1.736. And so, we probably could have done that over here, but slow down, let it take time. You'll get there. So this represents 10 to the 1.736. Now, the third one, number C, is 10 to the negative 2. It doesn't matter whether it's positive or negative. The same thing as far as when to add and when to multiply is going to be true. So this is going to be true for all numbers. I start with a number I'm given, 10 raised to the minus 2, and I substitute in e, the base e to the 2.303, this time raised to the minus 2. Well, nothing has changed. All I need to do is I have to know when to add and when to multiply. In this case, I simply multiply. And this one I can do almost in my head. It's just now it's going to be a negative number. So that's going to be equal to e to the minus 4.606. And now the last one is going to be the one with the most difficult multiplication in it, and that is e to the minus 1. So I start out with that expression again. It's just a negative number, which doesn't complicate things at all. The same rules of multiplication apply. I have to substitute in 10 to the 0.434 for the e term, and this is raised to the minus 1 power. And so I might be able to pull this one off without scratch paper, because I have to multiply times minus 1 this time. But it's still the same thing. You have to know when to add, when to multiply. This is one of those multiplication things. So it turns out that's going to be equal to 10 to the minus 0.434. And the rest of the exercises, there is a key provided with the handout. So I recommend that you go through and do all of the exercises. And if there's any questions, you can come to me and we'll work on it in office hours.